And now we're going to check out the retractable purge mechanism from BigBrain3D. Hello everyone, I hope you are well. Chris here back again with another multi-material video. Only this time we're going to tackle that purge block. The white tower that wastes a whole lot of filament that no one likes. And we're going to do that with a mechanical purge mechanism from BigBrain3D. And rather than me try to explain how it works, I think a video for this is worth 1,000 words. So let's check out their site. So basically what we're seeing here is anytime you have to purge and go to a different color, it's going to run over to the side, use this purge mechanism to make a plastic bead rather than to have to build the whole tower. It's going to dump the bead, switch out the color, and then go back to printing. And our goal here today is to get this whole thing set up and see if it actually saves us some filament. So basically we're going to continue on from the last MMU2 video a couple of weeks ago. I have a few more upgrades for the MMU2 and things I'm going to change, and we're also going to use proper spool holders. And one of you in the comments left me a link to a gravity spool holder that I really like. Let me show you that real quick. So basically what we have here is you attach your filament onto a threaded rod that has two gears on the side. These are designed to use with that Purge plastic tray. I don't have mine any longer, so I did print some. They are available in this file set, link in the description. But you put your PTFE tube down here, run your filament through. Then as your MMU picks up filament, it backs the spool up. Then when you retract to put the filament away, gravity brings it back onto the spool. This is an ingenious idea. So if you don't have a filament system already, or you might be having problem with the rewinding spools, check these out. And I am very confident that this new spool holder is going to make my life a whole lot easier during a long MMU2 print. And I am going to print the same model we did in the previous MMU2 video, this Rubik's Cube. And we're going to compare the weight of the beads from the Big Brain kit to the white tower we created in that video, just to see how big a difference there might be. So let's get started and see what you get in the kit when you order it. So here's what you get when you order the kit. All the printed parts, we'll go over what all these are when we're building it. You get a couple of different screws, some sweet stickers, some grease, some Captain tape strips, some aluminum tape, 4 springs, a thumbtack that has been cut to the proper length, and a washer that has a section cut out of it. Now if you want to build this yourself, just print your own parts, you can cut the washer yourself. They have instructions for it, as well as cut down a thumbtack and cut your own Captain tape, and you can get aluminum tape pretty much anywhere. But the kits are only 35 bucks, and it's a really ingenious design. So definitely consider grabbing yourself a kit rather than printing it yourself, just to help the company out. They've done some of the more tedious work for you, like cutting the tape and the washer. Just consider that when you're looking at purchasing one of these. So the first thing we're going to do is take our thumbtack that's been cut down, and we're going to put one of these Captain tape pieces on the back of it. These are about 50 millimeters in length if you have to cut these yourself. We're just going to put that across the back of the tack, somewhat centered, leave about the same amounts on both sides. Then we're going to take our catcher piece, and the pin part of the thumbtack is going to go in this hole. We need to fish the Captain tape through the back here. You can do that with pretty much anything the Captain tape will stick to. But we'll just fish it through, make sure that tack is in the hole, then we'll flip it over. And just lay that tape right down on the back. Just like that, to make sure the tack isn't going anywhere. Then we'll take our cut washer with a pair of pliers, and we're just going to slide it in these grooves right here above that tack. It sets in there just like that. This is actually where the nozzle is going to come to make that bead. So that's why we have these metal parts. Next we'll take our main bracket and our pivot arm, and it goes in this hole right here. Make sure it turns freely. We might put a little grease on that before we get the whole thing together. Then we'll take our foil tape on my cutting mat here, and I'm going to cut a 5mm wide strip. And we're going to wrap it around the end of the flicker arm right here. Again, we're putting the tape on just so it's a little more heat resistant. Just like that. Now we're going to take our wedge piece, our connecting arm, our assembled catcher, and our flicker arm, and put them together. Your wedge piece has this little part that sticks out on one side. That's the side that your flicker arm goes in. Just like that. Then your connector piece will go down opposite the wedge piece, just like this. And the whole thing will go on your catcher arm right here. Now we'll go back to the base and get some things assembled. We'll go ahead and put some grease on our pivot arm. We'll thread our catcher assembly through the bottom of the base, just like this. Your wedge will fit down in here in this base section, and then we're going to put a screw in from this side. It looks to be around an M3 by 12 cap screw. It'll go right in here and then thread into the wedge printed part. Just like that. And now we want to make sure that our mechanism is turning freely. You should have it where the flicker is down, and when you pull out, that's going to help eject that piece. This is where it catches, then it kicks it out just like this. Then we have our pivot arm. It has an open loop that goes on this side, and then there's a closed loop that goes on the bracket post. And before we put it on, it goes in this hole right here. It has to line up with our catcher arm and our action arm up here. So it'll need to go in this hole, down here at the bottom, and then this tab on the top will have to line up with the divot in the action arm. Then we can press it into the mounting hole, just like that. So make sure both of those are in the correct place before you put it down. And then from the back, we're going to use our other M3 by 12 cap head screw to attach the pivot arm. And with that attached, now we can put our springs on these posts. These two will go on this post. These two over here will go on this post. I'm just going to force them on with my O-ring pick. First two are on. And the last two are on. And the whole mechanism should move just like this. Before you put it on your printer, you might want to work it quite a few times, maybe 100 times or so, just to make sure everything is moving freely and it doesn't get hung up. And then we need to put our cage piece on. I totally forgot to film this while I was just doing it, but it slides in this groove right here. It needs to be flush right up here in the front. I did have to tap mine on. It is pretty tight. Here's what it looks like from the top. And then we need a piece of aluminum tape that goes right here. I'm going to cut out a 10 by 20 strip. And that's going to go all the way in here to the flat spot on that washer, about like this. And then we'll fold it over to the outside. And then there's a little divot in here. I'm going to work it into that divot with my O-ring pick. It should look something like that. And then we can put a little bit of our grease on any of our moving parts. The pivot arm up here, here in between, on the action arm, down here on the end of the pivot arm, this side of the catching arm, and we can deploy it, put a little on this side. Anywhere where there might be just a little bit of friction on those printed parts. We'll put a little up here on the connector piece as well. That seems to be one of the places that it really likes to catch. We'll clean it up a little. And it seems to be moving pretty freely. And it's ready to go. We're ready to put it on our Prusa. And on the printer, we're going to remove our right Z nut, just these two screws on top here. Then we'll take our mount piece and use those two screws that we removed from the Z nut, like so, and then we'll put it right back on that Z nut. It'll set just like this, and we'll screw it back down. Then we're going to take the screws off of the left Z nut, and we'll use those two on our cap piece to put that on the left side, just like we did for the mount on the right side. It goes back on just like this. Now the cap is on the left side, and now we're going to take our whole mechanism and the two countersunk screws they gave us in the kit, and we're going to put it on the mount over here on the right side. And our install is complete. But now you kind of get the idea how this is going to work. When you want to change color, the extruder housing goes all the way over here, hits the action arm, makes a bead of filament, lets it loose, kicks it out the front. Now, one of you in the comments mentioned that there was a replacement front PTFE holder, this part right here. And I do apologize that I didn't catch this in the last MMU2 video. This original one does seem to be working just fine, but I want you to have the most success possible. So I'm going to go ahead and replace this. We will have to remove this motor and selector again. So if you need to do any maintenance, now's a good time to do it. But this is what the new part looks like. The features are probably just a little bit sharper, so you have more success of being able to clip accurately. Just something to look into. This part is available in that same part set in the description of the last video. I'll add it to this one as well. But if you're having problems where it's not cutting, it's just pulling the filament, maybe consider upgrading to this part. This one looks to be marked R2. So I'm pulling these three selector motor screws out one more time. Going to slide this whole thing out and thread it off of the selector. Then we pull the rods and pull the selector. And then it's just these four screws to remove this part. All 5 of the PTFE tubes will probably come with it. Just swap these back in to the new part. Make sure the flange side of the tube is facing out. So facing out this way. All the PTFE tubes, our part's ready to go. We'll just slide the new part on and put our screws back in. Then we can just put everything back together. While I have it all apart, I'm going to go ahead and replace my blade as well. These are standard 9mm snap-off blades. You can buy these pretty much anywhere. So the hardware part of this is complete, and I'm going to say that was probably the easy part of this whole setup. Now we have to make some changes in the slicer so that it will actually actuate that arm when it wants to do a color change. So let's see what we got to do here to make this thing work. So we will get to all that slicer set up in a minute, but BigBrain3D has given us some tests we need to do to make sure the nozzle is in the right place to do the purge. You have a purge location test, then you have a purge blob test. They would like you to do the blob testing 500 times in a row to make sure you have everything set correctly. Then they consider that to be a go forward solution, and then you can start your prints. So let's just download these two G codes, see what's in there, and see what we need to do to line up our mechanism. So here's the purge location test G code. This is the one we need to do first. Basically what this is going to do is tell us if we're in the exact center of that tack with our nozzle, because that's where you need to be before you do your purge. Now I didn't have a lot of luck running this G code, so I'm just going to do it by hand, line by line, and that way I can show you what it's going to do as well. So let's just open up Pronterface, and we'll connect up. And the first thing this G code wants to do is just home the x-axis. So let's do G28 space X. So we've homed X. Now it wants to lower the motor current with an M907. We can do that. And then we're going to move X to 200 to get in position. G4 is a pause. We don't have to worry about that. Now we need to depress the arm. So we're going to move all the way to 250. But we need to raise the Z before we do this. If you do run this G code, make sure your Z is at a certain height. So I'm going to go ahead and raise mine up. Now that we're all the way up, I'm just going to zoom in on the mechanism because that's what we need to see next. So now that Z is up, let's move to 250. That should engage the mechanism. And we did partly. Then we want to move 5.5 more millimeters. This is the one that you need to adjust. So let's go ahead and do the recommended first. 255.5. The mechanism is engaged, but the question is that nozzle in the center of the tack? And this is going to be really hard to see, so I'm going to draw a line where the center of that nozzle is, so you can kind of track that silver spot as we move closer to the mechanism. So if we go to 255.5, like it states in the G code, we are actually a bit to the right of the tack. We need to be right in the center. So let's click back a millimeter. That looks better. We'll go back a tenth. 3/10. I think that looks a lot closer to the center of the tack. And if we do an M114, we are currently at X254.2. So in this G code, we'd want to change this line. And I'm just changing it for reference. We'll use this number in the next G code. So I'm going to save that. So now I'm going to start again, G28, X. I'm going to lower the current to 450. I'm going to send X to 200. Then I'm going to send it to 254.2. And once again, looks like our nozzle is really close to the center of the tack. So we have a good number. Now we're going to take a look at the next G code, the actual blob test. So we're doing a lot of the same thing. We're homing X, lowering voltage, moving to 200, then to 250. But our new number is 254.2. Then we're turning the fan off. We're setting extruder to 0. We're purging 40. Cooling the blob, turning the fan on full blast, that's the part fan. Waiting 12 seconds, turning fan off. Backing the filament up, and then moving X out. And on this second change down here, we actually move out a bit to 240, and then we come in a little further than even before. We were at 255. This one is 256. So I'm guessing what it's doing is coming in as far as it can to allow it to give it a little more snap, so maybe it'll kick out that bead. I think that's too far. Let's change this one to 255.5. We might have to tweak it a little bit, but we'll start there. And they want you to repeat this 500 times. So let's just save it to our SD card and run it once for now and see what happens. You will need to go ahead and preheat your printer because this G code doesn't do this. It doesn't do anything but move X. I recommend you leave your gantry all the way up. I'll pan the camera back up here in a second. But we're going to start that G code. Also, I'm going to load just some cheap filament I have to test it out. You can either do this with your MMU2 on a single filament, you can load it by hand, or you can just unplug your MMU2 and do it in standalone mode. And that's what I'm going to do for now. It just makes things a little less complicated. So I have the communication wires unplugged from the back of my MMU2, and I'm just going to undo the Bowden tube and feed my filament into the extruder by hand. And before we start the print, BigBrain does recommend that you turn off crash detection because we are colliding into that mechanism. So we'll go to settings and we'll make sure crash detection is set to off. So our gantry's up, we're up to temp. I'm going to go ahead and start this G code. Here goes nothing. If you get a warning about file incomplete, go ahead and say yes. We're going home. We have triggered. We are making a blob. We're cooling the blob. But we did not clear the blob. So it looks like the split washer that's on top here is having a hard time releasing the nozzle. It's actually spinning just a bit. So I'm going to put some aluminum tape on the back to try to keep it in place. So that bit of extra tape there on the top and the back of the washer should help a bit. Let's go ahead and give it another go. We'll start the G-code once again. We are making a blob. And it did kick the blob out that time. So let's try it one more time here. Restarting the G-code. Once again, making a blob. We are cooling said blob. And it kicked it out. So now, they want us to test this 500 times. So let's jump back to the computer. So I'm pretty happy with my code because we are able to kick those blobs out. But we want to make sure that it's going to work during operation. We don't need to G28X every time. So I'm going to omit that line from my copy. But I'm going to copy everything else. We'll copy. And then basically you're just going to paste it a bunch of times. There is probably a plugin that will do this for you, but it's not that hard to go ahead and paste it. Just remember we have roughly 30 lines. You can just keep hitting Control V. So 30 times 50, we're just going to keep pasting until we see it get to about 1500. You can just hold this down and it'll keep pasting continuously. It took about 3 seconds to do. There's line 1500. Now we'll save this again. Put this longer file on our SD card. Make sure your Z is up and you are still preheated. And let's just let this thing run. So far so good. We're just going to let this thing run. I'll spare you the 500 runs we're going to do. I'll give you an update here in a few. So far so good. It has missed the bowl a few times, but I think we've done about 40, maybe close to 50. We'll just let it keep running, see if we can get through all 500. So I've now run our G-code about 5 times. Remember we did 50 on that, so I'm going to do it a total of 10 or maybe more. And things have gone pretty well. I've got a lot of beads, but I've had a few failures. I highly recommend that you reprint the gate piece and the catcher piece. You might actually want to print a couple of these, because I think they're going to need adjustment as you tweak this whole mechanism. Make sure your foil tape is nice and laid down. I did break the gate on this, but it is still functioning. I also glued the top washer in place with a little bit of super glue. It might be a good idea to go ahead and glue that tack as well, but so far so good, it's hanging in there with the Captain tape. But where that washer is in the catcher arm, it sets right in here. I just put a little dot of super glue to help keep that washer in place because it was kicking it out occasionally. But so far so good. I'd say we were about 85% successful at this point. We'll keep testing. Okay, we have done it. 500, over 500 blobs have been printed. Now I have a few tips. So I already said make sure you print some extra parts, especially the arm and the fence. You might want to consider gluing that washer, the one that's on top, because it does tend to move around. And then on your tack, you have Captain tape that holds it onto the bottom of the catch arm. That Captain tape is to give you just a little bit more protection from the filament being hot when it makes that bead. But, as you probably know, filament likes to stick to Captain tape. So that can keep your bead from kicking out. So I recommend just finding something like a Q-tip or even just a toothpick and taking just a little bit of the grease that you put on the rest of the parts and rub it on the top of that tack. Because not only does it like to stick to the Captain tape, when it's cold, when it does its first blob, it likes to stick on that tack. Every other one after that, after the tack has been warmed up, works just fine. But just that little tiny bit of grease breaks that contact and it'll start working when it's even cold. So those are all of my tips. After you have it lined up and you start running through all of this test G-code, everything starts to pan out eventually. I'm pretty confident now that it can make a blob no matter what. I did also test taking one of the springs off of here because it was kicking the bead out quite far, but then it didn't seem to be kicking it out enough. So I still do have all 4 springs. So now I'm going to go ahead and hook my MMU2 back up. Then we will go to the computer, get us a test file, and get the slicer set up, ready to go to do a test print. And I'm just going to download these cubes that I like to test with. It's easy because they're quick prints and you get to see a lot of filament changes. And I'm just going to pull 3 of them in for now, just for testing purposes. Multiple objects, yes. Now the first thing we need to do is turn off our purge block here. So we'll go to print settings, multiple extruders, and disable wipe tower. We'll go back to the platter. The wipe tower is gone. And then we are going to paste in our pretty lengthy tool change G code here they have for us. So we'll just start at this curly bracket. We'll get all of it. Copy all the way down to here. Head back to Prusa Slicer. And then in printer settings, we'll go to custom G code. And this box right here is tool change G code. And we'll paste that. Then we will go back to their site. It gives you some tips on filament shaping, but it is pointed at PLA. So if you need to change to a different type of material, this is some settings you can use to do that. And then we're going to copy this section of G code. This is going to go in our start G code. This first one up here at the top. And it's going to replace our priming line. And we're just going to start here at this if statement and select all the way down to this last G92 and paste in the new start G code. This G code should create the priming blob. We might have to tweak it a bit just to see how this whole thing's going to work, but we're going to start here. And remember, if you made changes to run that test G code like we did before when we were just testing the blobs, we made changes to the X position, they need to be made in your tool change and if you're using the start G code as well. There is change this line for you so you know which one to change. My final value, the one I liked the best, was 2546. It gets me right in the center of the tack. You need to make those changes anywhere it says change this line. The first one, 2546, that's purging. The after tool change purge G code, 2546, right here. And then the third one, 2546, this is the extra movement where it tries to remove the blob. And then in your start G code, the first one is right here, extend arm, 2546. And then down here for that second hit. Just don't forget to make those updates. So we're going to go ahead and slice and get it put on our SD card. And then we can start testing. So here we go. I'm going to preheat. Then I'm going to go ahead and tell the MMU to load all my filaments. Because I always recommend you load your MMU2 before you start using it, just to make sure everything's set and it'll work all by itself. I'm just going to load 1, 2, and 3 for this test. My 3 filaments are loaded. I'm going to unload my test yellow filament. And now let's start our test print. Now for some reason with this G code, it's wanting me to remove old filament first. I don't know if that's something in the start G code or the tool change G code, but I'm not going to do it. I'm just going to go ahead and hit the button. And it resumes okay. So let's see where it goes from here. So we've leveled, we've moved over to the mechanism so we can prime with a blob. Now it's loading filament 1. Now it didn't make the priming blob after it did filament 1, and the nozzle hasn't been primed. So that's not good. So I think I'm going to change the start G code back to the regular prime line. So in my start G code, I'm just going to go to the default MMU2 printer configuration. And I'm going to grab the stock start G code, copy it, and then in my BigBrain config, I'll just select all and paste over it. We'll just go back to the prime line for now. I'm not sure what's going on, why the MMU doesn't like that prime blob like we're trying to do. But let's try this and see if we can do the filament changes with the blob. Definitely had to switch to a lower profile catching tray. Maybe like a cookie sheet or something would be best for this. This time it loaded 1 and we're doing the prime line. So it should go straight to the print from here. And then when it does the tool change G-code, it will make the blob. Now we're going to do our first blob. It should make one for filament 1. It's unloading filament 1. Now it's loading filament 2. It kicked out the first blob. It should be making the one for the second one. It's cooling the second one. And it kicked out the second one. We kicked out our next blob. We're creating the first one for filament 3. And we kicked out our filament 3 blob. So we've successfully changed 3 filaments. Let's let this test run and just see how it goes. So the test print is complete. Now I did have a few issues with the filament loading, but that's mostly because of how I have the filament set up here. All the purges went great. It made all the blobs just fine. So I think we're tuned in on the purge mechanism and we're ready for a larger print. So the testing is complete and the purging mechanism is working as intended. We went through that whole test print and no issues at all making those blobs. So now I think we're ready for a larger print. But I do have some concerns, the first one being with purging volume. Traditionally, if you needed to go from a darker color to a lighter color, you could increase the purge volume so you didn't bleed into the next color, like if you're going from red to white. That white's going to be pretty pink unless you increase the volume, and traditionally that's done on a white tower. With this scenario, you would actually have to do multiple blobs to get that amount of purge volume to be able to clear the color correctly. I'm not sure how that works right now, but I am going to investigate that later. Also, with the filament tip shaping, currently we're doing that in the G code, the one that we assigned during the tool change earlier. I would really like it to have it do it by the Prusa slicer settings, and there is a Python script out there for that, so I am going to try that as well. But other than that, let's go ahead and move to the larger print and just see how this whole thing's going to turn out. So that didn't go at all like I wanted it to. I made 6 attempts at this cube. I have many hours invested in it, and the one that you saw in the time lapse was the best that I could do. But before we take a look at it, I did want to thank BigBrain3D. They did support me through this whole thing. They were very responsive, but even with their help, I couldn't get a successful print. And also Sergio over at HVAC A to Z, he sent me this kit to try free of charge, so that was much appreciated. So let's take a look at what the mechanism looks like right now. You'll notice that it looks a whole lot different than when we started. That's because I broke it roughly 4 times. And it seemed to be all for different reasons. And the reason why it failed the last time was because it broke one more time. I had to replace the pivot arm, I broke the tip off of it. I broke this catcher arm twice. One because it was stuck out when the Z went down and snapped it off. And I also broke pretty much every one of these gate pieces that I put on. This one is broken as well. And each time you make a change to this mechanism, you have to switch out a part. You can't just try again. You're going to have to go through that sequence again to be able to tell where the nozzle is relative to the middle of that tack. Because not all of these parts are going to be the same depending on how you printed them, what printer you used. So if you get a failure in the middle of a print, you can try to replace that part, but most of the time you're going to have to start from scratch. You'll also notice that pretty much every spare gap on this printer is full of these little plastic blobs. This even caused me to fail Z-homing once. You can see all of them collected back there in the extrusion as well. And here's a look at the final print. The bottom bracket on the catcher arm actually broke and caused the printer to skip. And since you have to turn off crash detection, you can't recover from it. You can see where it skipped and tried to continue printing. It just didn't work out. One thing I did notice though, when using this mechanism versus the wipe tower, just take a look at the pink filament. You can see how much darker this one is versus the one using the mechanism. It actually does a better job than building the wipe tower at purging from filament to filament. So that is one positive here. I did notice that when it was doing all of its operation, it would actually make 2 beads every time it swapped. So that helps get the filament clear. So I really do kind of like this mechanism. It's fun to watch, I think it's really interesting, and I think there are advantages to it over the wipe tower, especially when you look at the color bleed on both models. But the big question I had, if it did work successfully, would it save you plastic? And I think we can still kind of get an idea about that. So our finished print doing the wipe tower weighs 98 grams. Our roughly 3/4 finished print from the mechanism weighs 80 grams. So we don't have to get too scientific on this. Let's just call that roughly 80% of the amount of the whole print. If you weigh our wipe tower from the complete print, it is 254 grams. And if we weigh all the beads and extra filament that we created during the mechanism print, we have 186 grams. And let's be honest, a lot of these fell on the floor or got stuck in the printer. Some even fell inside the print. That's kind of another disadvantage. You can see a picture I took when that happened right here. The blobs have a mind of their own and land on the print bed or wherever they might want to land. But just take that into account. Even if this was 20 grams heavier, it's still a lot less than that wipe tower. So I do think it saves you filament. So I did really want to make this thing work. I watched it for hundreds of hours through multiple prints, and it would go just fine for 8 or 9 hours at a time, but it seemed like as soon as you turned your back on it, one of the blobs would get stuck on the arm, or something would break and you'd have to start all over from scratch, because there's just no failure relief here. And having the crash detection off makes it even worse. Maybe if you could leave that on, you might be able to recover from some of these issues, but still not all of them. If you don't have it set up just right and the right tolerance on your printed parts, you're never going to be able to get that consistency through these hundreds and hundreds of filament changes like on some of these multi-material prints. It was a lot of fun to test, and I do appreciate BigBrain3D, their ideas and their support, but I don't think this one's ready for prime time just yet. I hope you liked this video. If you did, please let me know in the comments, and I will see you very soon on the next one. No more multi-prints for a while. I can't handle the stress.